Good morning, my dear students. Okay, so today we will discuss the bonding, chemical bonding. Already I have told you chemical bonding are two types. First one, ionic bonding, and the second one, covalent bonding. And another one, third type, that is coordinate bonding. But here we discuss only these two, ionic bonding and covalent and bonding. This coordinate bonding we will discuss it into the class 10. Okay, so first thing, ionic bonding is ionic bonding. Already we know how cations and anions are formed. How cations and anion is formed, that we know. That is according to the octet rule. What have done? Suppose sodium has 11 electrons, so its electronic configuration is 2, 8, 1. So sodium will release one electron, and then it's 2, 8, and this one is sodium plus, this one is cation. So like this Cl, it has 17 electron, 2, 8, 7. So they will accept the electron from the outside, and then Cl minus is converting into 2, 8, 8. They all are fulfilled of octet rule. Now next, Na plus Cl minus, there is electrostatic force, and then it will make NaCl ionic bond. NaCl ionic bond. Okay. Generally, ionic bonds are very much stable. Why? Because there is a attraction forces involved in between the opposite charges. In the cation and in the anion, there is opposite charges are made up, and then it will, in between that, electrostatic forces there. So ionic bonds are very much stable. That's why ionic bonds melting point is very much high, boiling point is very much high. Okay, so next we will discuss another compound, another ionic compound, calcium oxide. Calcium oxide. Calcium 20 atomic number, so 2, 8, 8, 2, and oxygen, it's 2, 6. Generally we will not draw like this. In your book one formation is there, another one is electron dot structure. Okay, where what we will do in that case, suppose calcium 2882 electronic configuration, okay, and oxygen, that is 26. We will just draw the valence electrons. Suppose Ca, it has 2 valence electrons. We will draw the only 2 valence electrons. In case of oxygen, we will draw just 6 valence electrons. Then it will give it calcium if its electrons to the oxygen, and then it forms Ce2 plus oxygen 2 minus, then electrostatic forces involved in between them, electrostatic force. Then calcium oxide is formed like this: potassium bromide, calcium chloride, magnesium chloride. Formation of magnesium chloride is given already in your book. Okay, this type of phenomena is called electron dot symbol or Lewis symbol. Electron dot symbol or Lewis symbol. Okay, so very good. Now come to the covalent bonding. In the covalent bonding, generally there is mutually sharing of electrons. In the covalent bonding, mutual sharing of electrons. Covalent bonding, mutual sharing of electrons. Okay, and covalent bonds are three types: single bond, double bond, and triple bond. Single bond means in between two atoms only one bond is there, A. Double bond means in between the atoms two bonds are present, and triple bonds means like this. Okay, don't mix it up like this. Suppose any molecule here, three bonds are present, then generally you say 1, 2, 3. These are example of triple bonds. No, in between the atoms if three bonds are present, then we call them example of triple bond. This one is a single bond compound. This one is single bond compound. Okay, now let's see how it is formed. First we will practice a single bond compound, and then double bond, and then triple bond. Okay, by that electron dot structure we will just draw this. Suppose HCl, hydrogen chloride. Hydrogen has 1 electron and chlorine has 7 valence electrons. Atomic number of chlorine is 17. So you people will draw the electronic configuration of chlorine. Then you get that is a valence electron of chlorine is 7. Then they are mutually sharing. When they are mutually shared the electrons, then we will just bracket up then for understanding, and then they will make a bond. This one is single bond. Single bond. Double bond. Suppose O2. Oxygen has valence electron 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. If there is 2 sharing, then we will give 2 brackets in between the electrons. So it produces double bond. 1, 2, 3, 4. 1, 2, 3. nitrogen is 5. N 1 2 3. 1 2 3. And nitrogen 1 2 3. 1 2 3. Then N double triple bond N nitrogen N2 triple bond. Example of triple bond. So practice more structures from your book, okay, and if any problem is there, then feel free to contact me. I will solve your problem, okay, and practice the question answers in your question answers from your book. Question answer from your book. And one more thing, that is one more thing you have to remember. This is a very important fact. This one is just very important fact. When you are in the class 8, we already know that when in a compound oxygen is added and hydrogen is removed, then we call them oxidation, and when oxygen is removed, hydrogen is added, we call them reduction. But now you are grown up, you are in the class 9, so one more concept is there. Always remember, that is, in any reaction is there any loss of electron of any element, loss of electron in any element, then we call them oxidation. Loss of electron is always oxidation, and gain of electron in any element, reduction. Gain of electron in element, that is reduction. So suppose Na, sodium, it has one extra electron, so it will donate its electron, so Na plus electron, so it donates, that means it releases, it loss, then this one is oxidation. When Cl, it forms Cl minus, Cl to Cl minus, then one is minus plus it. Okay. Then plus electron. Then it forms Cl minus, so electron gaining here, gaining of electron in any element, that's why this one is reduction. This one is reduction. Always remember. Okay. So up to this, thank you.